Hi everyone. In this given video, we are going to explain how can we solve minimum genetic mutation. A gene can be represented by an 8-character long string with choices of A, B, C, D. So what are the mutations that are possible? It would be A, B, G and T. Okay. Suppose you need to investigate a mutation of a gene starting from a particular gene and which ends at a particular gene. So here, right, it has been given that this gene gets transformed to other gene in one mutation. So how it is going to work out, we have to find it out. Let us take this example. A C C G G T T. So there would be an 8 possibilities of where the gene transformation might happen. So basically, right, this A can be changed to, it can remain A, it can change to B, it can change to G, it can change to T. So here, right, we are going to have a visited node or visited visited set to track whether a particular gene is does not get repeated again, and we are going to have a bank so that we are going to take account of the genes that are transforming. So here, right, if I see, right, if even if the first character A changed to B, G and T, right, it is not satisfying the bank condition. So what we can do, again, this is getting matched, CC is getting matched, GG is getting matched, T is getting matched, but this T is not getting matched. So this can transform to A, B, G and T. So if it's transformed to A, right, so the value of this gene is going to be AAC GGT TA, because it got transformed, so it is going to be A. So how many moves or how many steps it took us? So it took us one step. So we have to only mutate the genes to the position, right, which are available in bank. And once we have reached to this gene, right, we are going to add that to the set, to the visited set, so that it does not get repeated, because there could be a situation, it's a very straightforward, but here, right, if I look into the number of possibilities that can happen, right, it would be, right, 8 into 4, so 30, uh 32 possibilities of gene that could happen. Out of this 32, we are going to take in the gene mutations, right, which are available in the bank, so those are only is going to get considered. And once we consider gene, right, we add those to visitors so that it does not get repeated again. So that is the idea. To do this, right, we can use a graph, and this type of problem, right, it's always better to use a BFS type of solution, so breadth first search, because here, right, we have to traverse all the values in a sequential order. So I suggest, right, whenever there is an possibility of finding the minimum values, right, or minimum number of steps, right, it's always better to use a BFS type of solution backup, because that is going to give you the minimum number of steps to reach from point A to point B. So now let us jump to the Python solution, where I'm going to explain this problem and code down the solution in more detail. The first thing that we need to do, right, we need to write down the number of mutations that are possible. So mutation, it is going to be a list. So a possible mutation is A, then another is going to be C, the other is going to be G, and the last one is going to be T. Once that is done, right, we can add our queue. So let me import it. So from collections, import dq. Here, right, let me create my queue data structure. So q equal to dq, and here let me add the first value or the starting variable, append start gene, and number of steps that is required is going to be 0 initially. Then I can create a visited to keep a track of the values that already been visited so that we do not reiterate it again. Visited is going to be a set value. Now I can say while q, here I can say gene and moves equal to q dot pop left. Then for I in range 0 to 8, because we know there are 8 characters in a particular gene, right? So there would be 8 possibilities. Now one thing to get right, because the gene that we got right, it's a string value, so I need to convert it to a list. So I can say gene or let me gene mutate equal to list of gene, and here I can say gene of mutate. So I got the list out here, and then I can say for m in mutation. So what I can do, gene mutate of I is I'm changing that value to m, and I can basically say gene mutate str, and I can just again join this entire thing to form the string value. So gene mutate, so I'm converting it back to string. Now I'm going to check if gene mutate str not in visited, and if it's not in visited and it is basically in bank, in that case I can say visited dot add this gene mutate str. At the same time I also had to add it to our queue, so q dot append and gene mutate str with moves +1. And once that is done right, it should work. And in case it finds a value, it is going to return it, and else it can return -1. there is one thing that we need to do, which is basically if the gene value is equal to end gene, in that case I can return the moves. So it's pretty straightforward in that way. So let me run the code. As you could see, the public test case is passed, and let me submit it. I hope it should work. As you could see, it worked successfully, and the time complexity of it, right, is basically uh, the 8 into, means there could be so many possibilities, right? So means it's a, in a way it's a kind of a solution which is going to work. So as you could see, it's beating 100% of the submissions. It's pretty efficient in that regard. So that's all for this video. See you in the next one.